Hello students, so continuing our lectures on Matlab, uh, we have studied in our last class that how to assign vectors or arrays. Means if you assign x as 1, 2, 3, so it will give you a row vector. Now what about matrices? Instead of a single column or a single row matrix, a single column array, what about how to assign a matrix? So for that, what we have to do is we have to write the rows separated by semicolons. 1, 2, 3. Say 3, 2, 1. And say 1, 3, 2. That then you will get the value of, we will get the matrix as 1, 2, 3, 3, 2, 1, and 1, 3, 2. This is how you can represent the matrix in the Matlab. Now, as you all know, the matrix multiplication and addition, so you know that if we assign a number C as say 2, okay, and by the way, this semicolon means that we are not wanting any output, although we are assigning no output. Although we have assigned this number to this variable, we don't want it to be displayed on the screen. Okay, now we have assigned the value to a number C, and now if we multiply C with the matrix that we have initially assigned the value, then every element of that matrix will be multiplied by the C. So the answer will be that was 1, 2, 3, 3, 2, 1, 1, 3, 2. So answer will be 2, 4, 6, 6, 4, 2, and 2, 6, 4. So every variable gets multiplied by this number. If we have a similar, now this is a matrix, but this is a matrix of order 3 cross 3. So if we have another matrix, say Y, we will assign another matrix, say 1, 1, 2, 2, 1, 1, and 1, 2, 1. So Y is 1, 1, 2, 2, 1, 1, 1, 2, 1. So this is also a 3 cross 3 matrix. So we perform the operation x plus y. As you know that for any addition to take place, the borders of the two matrices should be they should be of the same order. So in this case, they are of the same order. So they will add up. So 1, 3, 3, 2, 1, 1, 3, 2. This was the matrix, I think, assigned to x, 1, 1, 3, 2. So, and so the answer would be 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, 1 plus 3, 2 plus 3, 5, 1 plus 2, 3, and 1 plus 1, 2, 1 plus 1 again 2, 2 plus 3, 5, and 1 plus 2, 3. So this will be the answer. Now what about matrix multiplication? So you know that for matrix multiplication, if we have an m into n ordered matrix, the matrix with which it gets multiplied should be have say n into p. So if you want to multiply this matrix with this matrix, so the resultant matrix will be of the order m into p. This is what we know. Now if we have a matrix x is equal to say 1 to 3, 3 to 1, and 3 2. So this is a 3 cross 3 matrix. So the matrix with which it gets multiplied should be 3 into anything of order. Let's take a 3 into 1 matrix. So if we have a matrix, say Z is equal to say 1, 2, 2. Matrix 1, 3, 2, then that will be Z is equal to 1, 2, 2. Now this cannot be multiplied with this matrix because this is of the order 1 into 3. This 1 into 3 order. It has to make 3 into 1. So to do it, so let's write here. So Z we have written as 1, 2, 2. I think this was the matrix. 1, 2, 2. We need to find out the 3 into 1 matrix. So what we will do, we will write Z conjugate. Z conjugate will be answer will be simply the complex conjugate. So complex transpose. This actually corresponds to complex transpose of the matrix. So since there is no complex number, it will only take the transpose part. So that will make the answer as 1, 2, 2. Now this is a 3 cross 1 matrix now. So it can be now added, or it can be now multiplied with the X matrix. So if we perform X multiplication this prime, so X is 1, 3, 2, 3, 2, 1, 1, 3, 2, sorry. 1, 2, 3, 3, 2, 1, 1, 3, 2. So this gets multiplied by Z prime. So the answer will be 1 plus 1 1 into 1 1 plus 2 into 2 4 1 plus, so this becomes 1, 2 into 2 4, and then 2 into 3 6. So you added this one, so the first column is 11. Secondly, again 3 into 1 3, 2 into 2 4, and 1 into 2 2. So this becomes 3 plus 4 7 plus 2 9, and the last one 1 into 1 is 1, plus 2 into 2 is 4, 3 into 2 is 6, plus 2 into 2 is 4. So again this becomes equal to 11. I think my calculation is right. So the answer becomes 11 9 11. So this is the answer. So as we started with, we have multiplied 3 into 3 matrix with a 3 into 1 matrix. So this becomes common. So ultimately we get a 3 into 1 matrix. So this is the 3 into 1 matrix. There are a lot of operations somehow in Matlab. Some of them we have already discussed in our previous section, to giving a focus, giving a light on some more operations. Right. This we already discussed. You can see here. The sin x, cos x, tan x, and a sin x. This is very common. So a, these are the trigonometric function, and a sin x computes the arc sine or inverse sine of x. Similarly, we have a cos x, a tan x, a tan 2x. This is important because it computes the tangent or inverse of the tangent of x depending on the sines of x and y. Again, similar to this, we have the hyperbolic functions. Here we have the inverse hyperbolic functions here, and we have some online help functions, like help means list topics on which help is available. Help win means opens the interactive help window. A help desk means opens the web browser based upon help. Help, then that is in help topic, and look for string, list the topics containing the string. That's all the operations. This is how the interactive window of the Matlab looks like. I can see that this is where we write the commands, and you've seen that we can use a Matlab for arithmetic operations as well. Now, like here, it has been used for an arithmetic operation. You can see we used here for an arithmetic operation. Sorry, bit operation, and the interesting thing is that the answer that has been obtained here, this answer we can use this for further arithmetic operations. See here, the value answer has been taken. And Matlab can assign a new value to answer, which will be used in the further calculations, like here.